Well, hey folks, and welcome to Solar Cabin Channel. Over the years living here off-grid, I have designed many different projects. Some of them worked well, some of them maybe not so well. I've designed solar air heaters, solar dehydrators, solar composting toilet, use a solarium. I use solar for everything pretty much around my cabin. And one of the things that people ask me a lot is, what do you do for air conditioning at your cabin? So I'll explain that, and then I'm going to explain this new project that I'm going to start working on. The air conditioners that I use at my place are called evaporative coolers. Some people call them swamp coolers. This is a mini swamp cooler. It actually works, if you know how swamp coolers work. You fill a basin with water. It has a basin down here. I fill it with 2 cups of water from my well and close that up. And then it has a filter in here and a little pump, and all it does is it pumps the water up through that filter, and then when it's plugged in, and this uses a USB cord, it only uses about 25 watts, and I can put it on medium, low, or high, and run it through that, so the water is going through, and then it evaporates as the air is pulled through that water. It cools the air down, and it cools down a small space. Now this is all I use here at my cabin because I live in what is called high desert. I'm at the foot of the Rocky Mountains in the southwestern part of the United States, so I don't have a lot of high humidity. In fact, our humidity is very low. This adds humidity when it is cooling to the cabin, and we need a little bit of little moisture in our air because it gets really dry here. And so this unit I use from early spring until it gets summer and starts getting hot. This is all I need and only uses 25 watts. So running off my solar power system doesn't even notice it, that it's running, and it can run all night. I just have to remember to fill it up with a couple cups of water, and that usually lasts 4 to 5 hours. Great little units. This is made by Ivation. They were on Amazon. I think they discontinued making them, but you can probably find a unit similar. I'll put a link down there in the comments. Now, this has been a great unit here for, like I said, if the temperature gets up around 80 degrees or so like that, this will work up until about then. Once it gets over 80 degrees, then I need something bigger, and that's when I bring out the big guns. And I have done videos on these before. This is the Air swamp cooler. Bring this out when the temperature climbs above 80 degrees. This works on the exact same principle. It has a water container at the bottom, and it will hold up to 4 gallons of water. And I usually refill it from the bucket. It can also be filled from a hose or from your sink. It has a pump in it that pumps the water up. Water goes through a big filter in the back, pulls that air through that water. It cools that down. And this unit is actually, it's too much for my cabin if I have it directly on me, even on low. My cabin is about 400 square feet, 200 square feet in the downstairs where I spend most of my time. And this unit will actually get so cold that it freezes me out even on low if I put it directly on me. That's why I use a small one. When it's not really hot, I'll use a small cooler and only use this when it's really hot. When it gets into that 85, 90 degrees and sometimes close to 100 around here, not very often does it get that hot. Then I'll pull out this big unit and I'll fill it up. Usually it's filled up from my bucket, and that cools the cabin down very, very fast. However, a lot of people don't live in high humidity areas, and they need something else. So they're using compressor type AC units, window units, and window units or mini split units. The problem is those use a lot more power. This unit only uses about 25 watts. This unit only uses 85 watts. So I can run these off of just my small solar panel system, which is only a 400 watt system. I couldn't run a window unit unless I wanted to really add a lot of solar panels and a lot of batteries in order to run a window unit. Even a 5,000 BTU window unit would take a lot of power. I know because I have one. I have tried to use it here in the cabin, and it will work during the daytime, but at night or as the sun goes down, my solar power system isn't producing enough power to keep it running. It would drain my batteries down really quickly. So I've been thinking about this a lot, and air conditioning is a big issue for a lot of people. If you don't have air conditioning, it can lead to heat stroke. If you have a blackout, it could lead to possible death as a result of people not having air conditioning of some sort in their house. But if a swamp cooler won't work for you, then you're going to have to use a window unit that uses a lot of power. You may have to have a much larger solar panel system. Or if you're in a blackout, you may not be able to have any air conditioning at all. So I started thinking, well, how can we make an air conditioner that isn't an evaporative cooler, but uses a very small amount of power, under 100 watts? And in fact, this system, when I get done with it, should be right around 50 watts, okay? So it could be run off of a 100-watt solar panel. So what I'm going to be using here, which I'll explain. Let me set this out of the way. So this is my thinking. Now, I'm telling you now, I am not an engineer. My background is in architectural drafting. I have taken engineering courses, so I do understand the basics of engineering, but I don't pretend to be an engineer. So I'm hoping there's some engineers out there that will join in on here and can help me with some design features to make this system work and work even better than the way I plan it. Okay, so what I have here is a 12 volt, 24 volt, or 110 volt refrigerator freezer. These use a Danfoss type compressor. It isn't a Danfoss brand. Danfoss came up with the design many years ago, but many other companies, especially in foreign companies, this is probably made in China, use a Danfoss type compressor. They're excellent compressors. I have used these types of fridges here in my cabin now for over 5 years. I've done several videos on them. I use an Alpacool C20 fridge freezer that has now been running for 5 years straight continually, and only uses 45 watts. And I have two of them. I use one for a refrigerator and one for a freezer, just running off a 200-watt recharging system. Now this one is made by Calmdo. And I actually got this. I didn't pay for this unit, I'll tell you up front. I got this as a review unit. The company was new. They wanted me to review it for off-grid use. I did use it in my camper a few times. It worked excellent. But then I left it in my camper and pretty much forgot about it. So I already have two of these 12-volt fridges in my cabin. I didn't need this one. So it's just been sitting out there now for like 3 years. So I decided I'm going to put this to use. So what I'm thinking is what we can do. These units cool down to freezing very fast. In about 20 minutes, this can drop all the way from ambient room temperature down to freezing. So it freezes really fast. And you can keep cold stuff in it. It's designed as a fridge. So I'll show you here. It's designed to be used as a fridge. And this one has two compartments. It has the freezer and the fridge. The freezer and a fridge compartment for keeping stuff that you don't want frozen on the small side and keeping all your frozen stuff on the big side. And you can freeze water bottles in these. And then they will, because this is insulated, as you can see, it has a pretty thick wall. This has about probably 2 inches of insulation, maybe even a little thicker on the sides. But in the front here and in the back, it's got about 2 inches of insulation. And probably on the sides, it's probably got about 3 inches of insulation. They work like a chest freezer, so the cold air stays in the bottom, so they stay cooler because the cold air isn't dropping out like on a refrigerator. They're great units designed to be used as a fridge freezer for a camper or recreation or for an off-grid cabin or something like that. I can highly recommend them. They work very well. However, this one is going to be put to a different use. We're going to try and convert this into an air conditioner that doesn't create any humidity. And if we can do this, and we can keep it under 100 watts, I said this will be about 50 watts, if we can keep it under 100 watts, this will be an air conditioner that can be used to cool down, I would say, an area of about 200 square feet is what I'm hoping. And it won't create any humidity, and it could be run off just a small solar panel system, a 100-watt solar panel and a 100-amp-hour battery, which should be able to run it. Or you could run it off of any of the power stations, which I'll show you as we get going on this project. So let me explain how I intend to use this. As you can see, the lid on this is flat, and it has quite a bit of surface area up here. So what I'm going to do is I'm going to install a fan and an outlet on the top of this unit. Now the fan I'm going to be using, I also got off Amazon. This is called the eFluky. I have reviewed this fan. This fan only uses about 3 watts when it's running. It has low, medium, and high. And it has about a 4-inch blade fan. It actually puts out good airflow for a small fan. And I use this all the time on my heating system, actually. This is why I got it. I put this behind my propane heater, and I plug it into my power station using the USB cord. My propane heater doesn't have a fan on it. I didn't get the one with a fan on it. I use this instead, and I only kick it on when I need it, and that pushes the warm air out from my propane furnace, and I've done videos on that if you want to go look at it. So this adds a fan to blow and to circulate the air, the heated air from my propane furnace. That's how I've been using this. But I'm going to use this in summer now to create an air conditioner. Now, this uses a USB cord, or it comes with an internal battery that can be charged up, which will last about 4 to 5 hours. I use the USB. It's only 3 watts, uses very little power. It is about a 4-inch circular fan. So I'm going to take this and I'm going to cut a hole up on top of this. Now remember, I didn't pay for this unit. So before you go deciding to do this, make sure that you really want to take this chance. Maybe you can find an older one of these or one that's not very expensive to do this on. But I'm going to take this fan, I'm going to cut a hole so this fits in perfectly right there like that. Now some of these fridges have a USB port built into them, and so you can actually plug the fan directly into the fridge. This one does not have a USB port, but that's okay because I'm going to be running the fridge off of my power station anyway, so I can also plug this USB fan into my power station. So there will be the fan. That will pull air out of the room, whatever the ambient air temperature is, and that will go down into the fridge. Now this fridge is going to be on, okay? It's going to be running, and I am going to fill it with water bottles at first, and then I'm going to use the gel ice packs. Now I have ordered some parts for this unit that will be here in 2 days, but I'm going to go ahead and get a start on it so I'm ready for those parts when they come. And I'm going to go ahead and install a fan and go ahead and freeze it up, and I'm going to cut a hole, an opening for my outlet. And then I've got a adjustable louver vent cover that will go on here that's coming in 2 days. And I've got some gel ice packs, which will work better than frozen water bottles, that will go in this. So the principle is this. When this unit is on, at night and until I need it during the daytime to run as an air conditioner, it will freeze anything that I put in here. I will set it to 0. It will freeze the water bottles, or it will freeze the gel packs to completely frozen. And it does that really fast. Okay, and those will be in there. This will be on all the time. It uses about 45 watts and runs about 2 or 3 times an hour. Okay, the fan will only come on when I need air conditioning. I will turn the fan on. It will blow that cold air down into the compartment. It will go around those frozen bottles or frozen gel packs, collecting the cold air, circulate up, and then come back up through this vent out here. Okay? And the principle is really simple. It will circulate that air continually, pulling the warmer air out of the room, circulating it through that ice, getting it really cold, and then push the cold air out of the cooler to become an air conditioner. Now, if I use water bottles or a bag of ice, like you've seen some of the guys make a cooler and they put a bag of ice in it and they use a fan system like this, the problem with those is as ice melts, it also produces condensation. So then what you have is you're adding moisture to the room. It basically works the same way as these evaporative coolers because you're going to be adding a lot more moisture to the room. That isn't what we want. So I'm going to test this first with ice bottles, but understand that if I use the water and ice bottles, they will, as the ice melts, produce some moisture and condensation, and that's going to produce moisture in your house. But I've got gel packs coming in 2 days. Gel packs are about 30% more efficient, and they have a greatly reduced condensation level, almost to 0. And I may have some other tricks for using this to reduce the amount of moisture that is produced from this unit, so it is producing pretty much dry, cold air. That's what I want. That's what I'm hoping for out of this unit, is I want dry, cold air, the same as you would get from your window AC units. Okay, but at a lot lower amount of power. Because this fridge only uses about 45 watts and only runs for a couple times an hour, and the fan only uses 3 watts, we're looking at under 50 watts to run this air conditioner unit, if it works the way I plan. But I'm going to go ahead and get started on it, and then you can go ahead and kibitz in the comments and tell me what you think. Offer ideas for improvement. I know one of the things people are going to suggest is adding more insulation. I think we could do that with some foam core insulation board, possibly glued to the sides of this unit and to the top. My top and bottom may improve the insulation. Before I do any of that, though, I want to test the basic unit, see how it works with the ice bottles. Then we will start modifying it to see how much we can increase it. And once I have my temperature sensor gun, we'll be able to see if those modifications are actually doing anything to increase the cold air, and see if this works. I sure hope it works, because if it does, it might actually reduce the amount of energy that people are using for running air conditioners, which would reduce overall consumption of energy, and it may actually save some people's lives in an emergency or a power blackout. So let's get started. I'm going to go ahead and lay out my design for cutting my fan out and cutting my vent out, and we'll just go from there. Okay, so what I've done here is I've centered my fan where I want it. And I'm going to be putting it on this side away from the away from the controls for the fridge, and I'm going to just center it like that, and then I just used a magic marker, and I drew around the edges, and I just traced around the edges of the circle so that it will fit. Now this does have a slight lip on it right here, so this piece here should go down inside, and if I cut around the outside of this edge, it should slide right down in there and give me a nice snug fit. That's the hope anyway. Now I'm going to start this hole with my drill, because I want to save these plugs. In case this actually doesn't actually work the way I think it's going to work, I can always put these plugs back in, bond to it, and use this as a fridge, and I haven't done any serious harm to it. So I'm going to start this with my drill and just a small drill bit to get my jigsaw blade in. So I'm going to start out here on the outside edge, and hopefully I can do this without doing any serious damage. Right through. Another hole right next to it. And I'm just going to use my drill like a saw to get that started. Okay, so I got the jigsaw all the way into that starter hole there. Hopefully I'll be able to see this line well enough to do this, kind of cut around the outside. Let's see how I did. Cut all the way through. Now you get a chance to see the insulation too. See what kind of insulation. Oh, it has good thick insulation in it. A little bit stuck on that edge right there. Twist it loose. Hopefully I didn't mangle that hole too badly. You can see where I started drilling. There's the so there's the plug that came out of it, and you can see the insulation. It has, I'd say, at least probably 1.5 inches on it. So that's not bad, and that's really thick. It's really heavy, thick insulation. So there's my hole. Now the test is, did I make it big enough for the fan to fit in? I sure hope so. So there's the fan. Oh, look at that. And fits in perfectly. All right. We did a good job, guys. Now I will save this plug, like I said, in case in case this project ends up not working out. I can always put that back in with some Bondo, and my fridge is back in working order. But I think this is going to work. So there's my fan, and I've got my cord here that will go on the fan. And now I need to do the same thing for an outlet cut over here, and I'm just going to check my measurements to make sure that the vent I ordered, which is an adjustable louver vent, so I can change the directions of it to aim up or down or to the side or whatever. I'm going to put that over here. Now, on this louver vent, now some people will say, well, why not put the louver vent, the outlet on the side or on the end? Now, my thinking on this, and we'll see if it works out, is that by having it on top, some of that cold air is going to drift over and be pulled back down through the fridge. So it's actually going to recirculate some of the cold air, not all of the cold air, because it'll depend on which way I have the vent aimed. But it will recirculate some of that cold air along with the room temperature warm air back through the fridge, and that will cool it down even more. If you take cold air and you put it back into the fridge, it's going to absorb even more cold air as it's pushed out. So I'm actually getting a recirculation effect that should add to the ability to cool down the air that's coming out of the vent by having it up on top. We'll see if that works out. I don't know if that's going to actually work. We'll see if it works. So now I'm going to do the same thing, measure my hole for my vent cover that I'm getting from Amazon in a couple days, and cut a hole on this other side. I won't take you through that entire process. I'll just cut the hole and show you how it looks. Okay, before I cut this vent hole over here for this louver, I was just going to explain that the hole on this is going to be just a little bit bigger. I went online. This is the louver vent that I'm going to be using right here. And it has a 4 5/8 inch hole, and then it has a plate that goes out to about 6 inches. So if I'm off a little bit, it's not going to make too much difference because that plate will cover it, but I still want it fairly tight. So my fan, I used it to make my hole, and I just drew around the outside edge to make it a little bit bigger, and it should be plenty wide enough for that vent to fit over on this. So before I cut, I just wanted to explain that in case you're using the same vent and the same fan, you can make your holes the correct size. So I'll go ahead and cut this out, and then we'll show how it works. Okay, so here I've got both holes cut. Open this up. I had to flip it around so I had more room to work. And pull this one out. Oops, I didn't get the bottom. And there's the cutout for that one. That's the fan, goes on the control side, or that's the vent, goes on the control side. This is the fan that goes on the opposite side. And I've got my vent cover coming, which I showed you there, and we'll put that on when it comes. But I think we can go ahead and test this. I'm going to go ahead and put my water bottles in, set this on low, on at zero, and let it freeze. And then once everything's froze, I can put the fan on, and I can at least get air circulating out of here, so we can get some idea of whether this is going to circulate cold air. Before I put the water bottles in it and let this freeze, I decided to do a real quick test just to see how loud this fan is and how much air it's going to blow out of this. Now this is, again, the eFluky fan. It is a 3-watt fan. It is not a very powerful fan. We'll put it up on high. That's on high. You can hear it. We'll put that in here, like so. Now this is just running off of my power station down there. We'll put that in there like so, so it seals down good. And then we'll see kind of how much air is coming out of here. Now it's actually pretty good airflow, considering this is only a 3-watt fan. You can get these fans, these USB fans, up to 10 watts, and maybe even higher, but I know they make them up to 10 watts. So if you want more air coming out of it. Now, my thinking again is, I actually don't want a real powerful fan, because I want this air to circulate down underneath the frozen water bottles or the frozen ice packs, and then come out. And I want it to stay in this fridge as long as it can, so it collects as much cold air as it can before it comes out of the vent. I'm not trying to turn this into a tornado that really blows you away. This is just going to circulate that cold air up constantly into the room. And it has decent, we'll see if I can show this. So I use a piece of paper here so you can see how much flow it is that's coming out of there. I'd say that's pretty good flow. I'd say that's pretty good flow coming out of there. Not real powerful. I'll put it down right next to it. It's not real powerful, but you can see that it's putting out quite a bit of airflow. Slow enough that it will collect the cold that's inside the fridge and around the ice, and then expel it out into the room. And that's what I want, all right? So you can also tell it's very quiet. I wondered about that. This fan is very quiet, these eFlukies. And I think you can see the sound went up a little bit as I restricted the airflow. When I stopped restricting the airflow, it calms down. It isn't as loud. And so having this completely open, we should get good airflow out of there. And yeah, I would say that's probably plenty for my uses for this. If you wanted to get a more powerful fan, you can. But like I said, I just want a gentle, nice, cold breeze to come out and fill up my cabin, which is about 200 square feet. All right, so now we can put the water bottles in it and let them freeze. Run this. It'll probably take about 2 hours for everything to completely freeze. And then we'll test it with the water bottles frozen in it, see how it runs, and I'll explain some more of how this principle is going to work. Okay, guys, so I went downtown, got me some water, and I'm just using these, what are they, 16.9 fluid ounce water bottles. They're sealed, so I don't have to worry about them leaking. Just using them. I've got 8 of those inside the cooler here. I could put more. This thing will hold a lot. I could put 3 times that many, but I've got 8 because that felt about the same size as a block of ice. So that's what I put in here. Now these plugs, you can see that I just put them back in the holes while it's cooling down the initial time to freeze these so that it will freeze up faster. I just put these back in here, which you may want to do. Once it's cold, then it shouldn't have too much of a problem keeping that temperature with that ice in there. But we'll see. It was 57 degrees. It was 57 degrees it showed on the ambient temperature in the room. It is now down to 55, so it's going down. We'll see how long it takes for it to hit 0 to freeze this water fast. So I'm just going to keep it at 0. We'll see how long it actually takes to freeze that water. Then we'll go ahead and put the vents on and see how cold this gets. Okay, guys, so this is the first test of this unit. Here I've got the fan plugged in and turned on, and it is pulling 51 watts from my power station. So that's with the fan running and with the fridge running. The fridge runs approximately 48 watts, and the fan is pulling approximately 3 watts. And while I was downtown getting some water, I also found a dryer vent flap valve. This is not the louver vent that I'm going to be using on this unit, but it is directional, so I can kind of control the direction and shut it down because I wanted to play with the direction. Now, this is running right now. I've had it on for about 20 minutes, and I've already noticed a huge difference. This is blowing out very cold air. This is blowing out very cold air, as you can see the airflow coming. As you can see the air coming out of the vent. Okay? So you can see the air coming out of the vent. And I don't have a thermal heat gun yet to test it. That'll be here in a couple days, so I can tell you exactly how much cooler air is coming out of this. But I can tell you it's cold enough that if I was to stand directly in front of it, I would be too cold. Okay, that's an honest truth. And I actually had to put my shirt on because I got too cold when I was working around this. This is my indoor thermometer, and I can do a basic test on this. It was reading that my ambient temperature had reached about 75 degrees. So it was just starting to get to the point where I needed some air conditioning. Flip this on, and within 15 minutes of putting this next to it, this went from 75 degrees down to 65 degrees. So it dropped 10 degrees in 15 minutes. But the temperature of the air that is coming out of this unit is at least 10 degrees cooler than the ambient air in the unit. So the room could get up to 80 degrees, and it would bring it down to about 70 degrees according to my estimates. Okay. Now I'm going to do a lot more testing on this unit, because if this works as well as I think it's working, this would be an excellent small air conditioner for apartments, rooms, bedrooms, RVs, campers, things like that. And it may actually be something that the producers of these 12 volt and 24 volt, 110 volt refrigerator producers may want to include, because it wouldn't take very much to include a pan fan and a vent on the top of their refrigerators with a flap that you could close, so you could use it either as a refrigerator or in an emergency, or if while you're camping, you could just turn it on and use it for an air conditioner. Now, I will tell you, it is going to make the Danfoss type compressors run a lot longer, okay? Normally they would shut off and only run maybe 3 or 4 times an hour. It's going to run continually while it's doing this. So that may shorten the life of the compressor. I don't know. I think it probably would over time. But like I said, I've had my Alpico fridge with the same compressor in it running for 5 years straight without a single problem. I don't really think it would cause any serious long-term damage, other than maybe possibly shorten the life of the compressor if you're running it all the time continually. But that's not probably how most people would use this. Like here at my cabin, I'm not going to need this probably at night. Usually by 1 o'clock, the nighttime temperature drops down enough that I don't even need any air conditioning. Okay, so I could turn off the fan, and the fridge would just keep running, and it would freeze that water that's in there, because I've got 8 bottles of 16-ounce water in the fridge. It would freeze that overnight, okay, completely froze. And then the next day, when I need air conditioning, which usually starts around maybe 12, 1 o'clock that I need air conditioning, I can flip the fan on, and because those are going to be completely frozen, now I've got even colder air. The water bottles that are in here right now are not completely frozen, okay? They won't be frozen. They won't be frozen until probably tonight when I turn this off and I'll leave the fridge on overnight. But tomorrow they will be frozen. And when they're frozen, this air that's coming out of this unit is going to be even colder than it is right now. And just to give you an example, here it says my ambient temperature is around 75 degrees. I'm going to put this in front of this and I'll do a quick time lapse on it so you can see how fast this drops down. Okay, so there you can see it took the ambient room temperatures from 75 degrees down to 70 degrees from the air that's coming out of this vent in less than 5 minutes. So that's fast. And it is cooling down the entire cabin, but especially right in front of it. So this would work best in small areas, like my cabin is only 200 square feet. It would work like in a bedroom, it'd work well like in a bedroom, or a small area where you just need to basically cool yourselves down and cool this small area down that's enclosed, or in an RV or an off-grid cabin or something like I'm using here. This is not a whole house air conditioner, folks. This is an emergency air conditioner running at 51 watts that can be run off of solar panels, or run off of your AC system, or run off of a power station. And I know for a fact that the power station I'm using, the Geniverse power station, will run a fridge like this for 2 days solid without any extra power coming in. That's 2 days of air conditioning that would keep you alive in an emergency, in a blackout, a power blackout, or if you're camping, or if you're going off grid or something like that. You could have power. You could have your power station run your air conditioner. And here's the neat thing. It's also keeping that water cold in there. And if I wanted to, I could put food, or I could put my beer in there, and it would cool it all down too while it's running the air conditioner. It's still going to keep everything that's inside that cold. So you've got an air conditioner and a fridge and freezer all in one. Pretty neat. All right. That's my test on this unit for the day. I will continue to do testing as I get my new turbo vent, and I get my temperature sensor gun. I'll put this through some more tests, maybe try a different fan and a few things and just see how I can possibly modify it to get this to be even colder. All right, folks, I hope you enjoyed this video. Have a great day.